Feature Engineering with Pandas. Welcome! Today we will explore how to use Pandas for feature engineering, a core skill in data analysis and machine learning. Feature engineering is about creating new data columns that help models and humans understand the data better. We will use the Titanic dataset to practice each new concept step by step. Running the cell now. Are you ready to learn? Let us jump in. Let us set up our data before we start making new features. First, we will turn off warning messages to make the outputs cleaner. Now, we import the Pandas library, which helps us work with data tables. Import numpy as np. We set the random seed to 42 for reproducibility. We are going to load the Titanic dataset. This dataset has information about passengers on the Titanic ship. We fetch the data straight from a GitHub link. The data is read into a data frame, which is like a spreadsheet inside Python. Here, we print out the shape of our data, which means rows and columns. We also preview the first 3 rows to see the structure and some example values. Running the cell now. This output shows the Titanic dataset loaded with 891 rows and 12 columns, including key passenger details like age, sex, fare, and embarked. Notice the variety of data types and some missing values, e.g., in the cabin column, which highlights why feature engineering is essential for cleaning and enriching such data before modeling. This initial exploration sets the stage for creating new features that capture meaningful patterns. Notice columns like P-class, sex, age, sib-sp, and fare. These will be useful for creating new features soon. Why engineer features? Raw data almost never has all the information we need. By combining, changing, or extracting values, we help computers and ourselves make better predictions. On Titanic, for example, we can guess who had better chances of survival by making new features from names or families. Running the cell now. Let us create some example features. Traveling with family might have helped survival chances. Let us see how to build that feature. Let us create a new column called family size. This column adds up siblings, spouses, parents, and children for each passenger. We add 1 to include the person themselves. This line does the calculation and saves it in a new column. We print the old columns and the new column to compare. You can now see how large each passenger's traveling group is. Running the cell now. This output shows the new family size feature, created by combining sib-sp, siblings, spouses aboard, and deparch, parents, children aboard, plus 1 for the passenger themselves. Notice how this new column summarizes family presence more comprehensively than the original columns alone, which can improve predictive power by providing a clearer picture of social context. This illustrates the value of feature engineering in enriching raw data for better model insights. Try creating a family size column on your own next time. Sometimes, even a small detail like a title can tell you a lot. Here, we are extracting passenger titles like Mr., Mrs., or Miss from the name column. Titles can hint at age, gender, or status. This line uses a regular expression to catch any word followed by a dot, right after a space. We save it as a new title feature. Now you can see which title each name carried. This can help models sort people by groups. Running the cell now. Here, we've engineered a new feature called Titles by extracting honorifics like Mr., Mrs., and Miss from this named column. Notice how this transformation captures a key social attribute that wasn't explicitly available in the raw data, helping us better understand passenger demographics. This step illustrates how feature engineering uncovers useful patterns to improve prediction models. Notice rare titles like Mademoiselle or Major. These can be grouped later. Working with categories is sometimes more meaningful than seeing raw numbers. Let us practice binning. We are going to make age easier to analyze by sorting people into groups such as child, teen, adult, middle-aged, and senior. We define the ranges using bins. These bins are the numeric limits for each group. We then write labels for each group, describing the age ranges in words. With PD cut, Pandas places each passenger into an age group. This makes comparing groups simple. Now, you can see the age with its new label. Useful for group by analysis. Running the cell now. Here we see the ages grouped into meaningful categories like child and adult, turning a continuous number into a useful feature for analysis. Notice how missing values remain nan, reminding us to handle incomplete data carefully. This feature engineering step helps models better understand age-related patterns by simplifying raw data into clear age groups. Practice: what groups would you create for fair amount or number of siblings? Let us fix missing ages to prepare our data. This is a common real-world task. Working with missing values is a huge part of feature engineering. Here, we fill in missing ages with the median age for each group. First, we ask Pandas to give each age group the right median age. Next, we use fillna to add the median where data is missing. This is called imputation. We then print only rows where age was missing, so you can check what got filled in. Running the cell now. Here, the code attempts to fill missing age values using the median age within each age group, but we see that for some age groups, age is completely missing, so age filled remains nan. This highlights the challenge in feature engineering. When group data is absent, simple imputation won't fill gaps, reminding us that additional strategies may be needed to handle missing values effectively. Check if age filled looks realistic for these passengers. Sometimes, all you need is a simple yes or no feature. Let us try an is-alone flag. Now, let us make a feature that labels people traveling alone. This means their family size is 1. We compare family size to 1 and turn the result into ones and zeros. 1 means the person is alone. Printing some examples, we see that if family size is 1, is alone is 1. Otherwise, it is 0. Running the cell now. This output shows the new feature is alone, which is 1 when family size equals 1, indicating the passenger is alone, and 0 otherwise. Notice how this binary feature simplifies the original numeric family size at column to capture a meaningful pattern that may better help the model identify the impact of being alone on survival. This highlights how feature engineering transforms raw data into more predictive information. In many datasets, binary features can improve performance a lot. Let us see how to extract part of a text column with Pandas. Some cabin values are missing, but for those that are filled, we will take the first letter as the deck code. This code grabs just the first character from cabin. It shows which deck passengers were located on. Now we can compare passenger decks, even if most data is missing. Running the cell now. Here we extracted the first letter of the cabins to create a new to-deck feature, which simplifies the original data and highlights the deck level. Notice how missing cabin entries produce nan decks, showing that feature engineering can also surface data gaps. This step helps models by turning detailed text into more meaningful categories for prediction. You can extract first letters, words, or patterns by changing the expression. Sometimes, dividing two columns gives us a more useful variable. We can build a new feature by dividing how much a group paid by the number of people in the group. This gives us fare per person, a fairer metric for comparing passenger spending. Let us take a look at the original fare, the family size, and the new fare per person side by side. Running the cell now. This output shows the new feature fare per person, calculated by dividing the total fare by family size, effectively distributing the fare cost per individual. Notice how larger families with high total fares tend to have much lower fare per person values, highlighting the importance of scaling features to capture more meaningful relationships for better predictive modeling. This demonstrates how feature engineering helps refine raw data to reveal deeper insights. What new feature could you make using fare and p-class together? Most models in machine learning can only work with numbers. Let's convert text codes to numbers. Models often want numbers, not words. Here, we use map to turn male into 0 and female into 1. We print both sex and sexnum to confirm the mapping worked. Running the cell now. This output shows the new sexnum column created by mapping categorical values O male and female to numeric codes 0 and 1, respectively. Notice how this transforms text data into numbers, which is essential for most machine learning models that require numeric input. This feature engineering step helps the model interpret gender information effectively for better predictions. Practice, map the embarked column next. How many unique values are there? One-hot encoding is a key step in preparing features for most algorithms. For columns with a few category labels, we often use one-hot encoding. This means we create a new column for each possible value. The pd_get_dummies function does this for us for the embarked column. We then join these new columns to our main data. Look at the result. Each row now gets a 1 or 0 in embarked_c, embarked_q, or embarked_s. Running the cell now. This output shows the result of one-hot encoding the embarked column, converting categorical values into separate binary features, one for each port, C, Q, S. Notice how each row has exactly one true value indicating the original embarkation point, which helps machine learning models interpret categorical data numerically. This feature engineering step transforms raw text data into a format that algorithms can use more effectively for predictions. You can use this pattern for almost any text column with just a few unique values. Let us try combining information to create even more power in our features. Sometimes mixing two columns together creates a useful new feature. This is called an interaction variable. Here, we make a new column that connects p-class and sex into one label. For example, 3_male or 1_female. Combining classes and groups like this can help separate out important patterns. Running the cell now. This output shows a new interaction feature, class sex, combining passenger class and sex into a single value. Notice how each entry uniquely reflects both attributes, like 3_male or 1_female, making it easier for models to capture patterns influenced by this combination. Creating such features enriches raw data, helping predictions better account for how these factors jointly affect outcomes. Try mixing age group and sex to see if you catch new insights. Spotting unusual values, or outliers, is a useful step in feature engineering. We start by indicating that we will detect outliers in the fare column using a z-score method. We calculate the average fare paid by passengers. We calculate the standard deviation of the fares to measure how much fares vary. We create a new column with a z-score for each fare, showing how many standard deviations away each fare is from the mean. Finally, we print the first 8 rows of the fare and fare score columns to see the calculated z-scores. Running the cell now. This output shows the original fare values alongside their calculated z-scores, which standardize fares based on the dataset's mean and standard deviation. Notice how higher fares like 71.2833 have positive z-scores, indicating they are above average, while lower fares have negative scores. This feature engineering helps identify outliers and scale values meaningfully for improved model performance. Can you find the rows with the highest z-scores? Try sorting by fare score. Mini-project, Feature Engineering EDA. Let us pause and practice turning our new features into insight. We will ask if traveling alone or with family changed survival rates. Try to guess before running the code below. Running the cell now. Let us dig into some real questions about survival next. This is how you can analyze if a new feature is actually useful. Let us group passengers by whether they were alone or with family, and check their average survival probability. The mean shows the percentage who survived in each group. We can compare family advantage easily now. Running the cell now. This output shows the average survival rate for passengers who traveled alone, 1, versus those who were not alone, 0. Notice that passengers traveling with family had a higher survival rate, 50.6%, compared to those traveling alone, 30.4%. This reveals a key insight that traveling alone may have negatively impacted survival chances, directly connecting our feature engineering to meaningful patterns in the data. Practice. Try grouping by age group or class next and compare. The same grouping technique works for any categorical feature. Let us check survival rates for each age group. Grouping by age group and averaging survived helps us spot trends, like if children or seniors had better odds. Running the cell now. This output shows the average survival rate for different age groups, revealing that children had the highest survival at about 58%, while seniors had the lowest around 23%. Notice the general downward trend in survival as age increases, which helps us understand how age-related features might influence survival outcomes in our analysis. This insight supports our goal to explore how demographic factors like age and family travel status affect survival rates. Insights like this help focus your analysis and feature creation. Let us see our engineered features in action with a simple plot. Visuals make it easier to spot patterns. Here is a bar chart showing counts of passengers by age group and sex. We import matplotlib, the main chart library for Python. A crosstab gives us the counts, and we plot it as a stacked bar chart. This line adds a helpful title to the chart. Now we label the x-axis as age group. The y-axis label tells us we are seeing the count. A legend helps decode bar colors. Tight_layout makes the diagram fit better. Finally, we display the plot. This chart is great for spotting imbalances or gaps in groups. Running the cell now. This stacked bar chart displays the count of passengers across different age groups, separated by sex. Notice how the distribution varies between males and females within each age category, helping us understand the composition of our dataset before examining survival rates. This visualization sets the stage to explore if age and sex, combined with traveling alone or with family, influence survival outcomes. Challenge: plot survival rates by class, sex, or embark next. Feature engineering is not complete without a quick stats check. It is helpful to check if new features have any strong link to survival. With the core function, Pandas shows numbers from -1 to 1. Closer to 1 or -1 means a stronger relationship. Looking at this table, we can spot which features might help models predict survival well. Running the cell now. This correlation matrix highlights relationships between our new features and survival. Notice that is alone shows a moderate negative correlation, -0.20, with survival, indicating those traveling alone were less likely to survive, while sexnum has a strong positive correlation, 0.54, reflecting gender's well-known impact on survival. This quick check confirms that our engineered features capture meaningful patterns relevant to the survival outcome. Practice, add your own features and look for high or low correlations. Let us talk about a common mistake for beginners, making future information part of your features. When building features, be careful not to use information that would not be available for predictions in real use. If you copy the survived column, models can cheat. This is called data leakage. We print the current columns to see where the leak happened. Finally, we delete the leaked column so we do not make mistakes. Running the cell now. Here, we momentarily added the survival known column, which duplicates the target survived, then removed it to avoid data leakage. Notice the full list of columns includes both original features and our newly engineered ones like is_alone and family size, demonstrating how we've expanded the dataset to better explore how traveling alone or with family might influence survival rates. This careful handling ensures our analysis remains valid without accidentally revealing the outcome during feature exploration. Always keep your features clean of target or label info. Recap what we learned. Creating features by combining columns. Extracting information from text. Handling missing values. Making categories. Encoding labels for models. Checking for outliers and leakage. Practice these steps to improve any data project. Running the cell now. Try building 3 new features in a dataset of your choice this week. Keep practicing and subscribe. Want more Pandas tutorials and tips? Practice, pick a fun dataset, design and test at least 2 of your own features. Subscribe for future walkthroughs on Pandas, data science, and machine learning. Running the cell now. Great job getting this far. See you in the next video.